Okay, so we'll have a very short video describing both the primz and the kurskal algorithm. Okay, now what actually primz says is point one. Always start from the minimum uh, weighted edge. So select minimum cost edge. Now, over here, our minimum cost edge is actually 6, 7. Okay, so 6, 7. Okay, 9. Now, second thing, from either edge, start moving. Start building. Okay. Now, from 6 and 7, from 6 it's 22 over here, it's 19, and from 7 it is 16 over here. So I'll next select this. Okay, now so I just moved the graph. Now from again the second, where do you have to see? From 2 it's 14 over here and it's 24 over here, and from 7 both the possibilities have been done. So now I go to 3, 14. Okay, now again from 3 I have only one choice, that is 10. Now again from 4 again I have only one choice, that is 20. So 5. Now after this is completed from 5, if I complete 6 it forms a cyclic graph, and if I form 1 it forms a cyclic graph. So my next would be from 5, 6 and 5 is not recommended. Then I have a weight. From 2 it is 24 and from 6 it is 19. So 1. So I merely followed from 6 to 7, from just 6 to 7, 7 to 2, 2 to 4, and from here the 0.5, and over here I've skipped this one because it forms a cyclic graph, and again from 6 it forms 19. Now this is your primz, wherein the third rule will be skip cycle forming edges. Cycle forming edges. Now there you have it. The logic for primz algorithm is this: just start with the minimum cost edge, then from either edge see which is the lowest next edge and start building it. If any possibility comes like from 5 to 6 that forms a cycle, skip the edge and build it. Now let's remember now also remember, primz only works for a closed graph, that is a connected graph. Say for example you have unconnected graph. Primz doesn't work over here. When we start with 1, maybe it forms 2 and 2 to 3. Then unconnected graph doesn't work out. Okay, so maybe this will strike your mind. We need a next algorithm that might be even better. Next one we want to see is kurskals. Okay, now over here, so remember, point 1 is always select minimum edge, always. So for this, we can directly start building the graph, or we can start writing in a sequence. The minimum is 6 to 7, that is 9. Then the next minimum is 3 to 4, that is 10, and so on. You can write down and the weights of the graph according to ascending order and start building it. So the first one is 6 to 7. Now next one would be 3 to 4. Now 9, 10, and the next one would be 14. The next one would be 14, and after 14 we have 9, 10, 14, 16. Okay, so 6, 7, and excuse my handwriting over here. I am doing all this and between work, so 6 to 7, 7 to 8. Now just after 14, 16, then comes 19, then 19, 20. Okay, and then after 20 comes 22 and 24, but 22 forms a cyclic, and 24 also forms a cyclic. So there we have it. We have a graph, and the second condition, skip all if forms cyclic. Okay, so the final graph is that's it. Yeah, so just redo the graph a little bit neat. Now this is kurskals. Always start with the minimum spanning tree. That's why 6 to 7 has been written first and 3 to 4 has been written next. Apart from the non-connecting also, it doesn't have to really connect. You just keep drawing the smallest distance. Now, since you understand Kurskals algorithm, I already told you about the previous thing. We have two graphs. Okay, so it is 1 2 3 A B C D E, it's E F G, 2 3 1 4. Now even if it is an unconnected graph, look at the way we start with the minimum 3. So 1 B C and E F. Okay, 1 1. Next here write 2, and over here also write 2 D G. The next value is 3, but if this is 3, it's a closed one, so we don't write it. And over here too, D and E, we write it now. Okay, and the last one GF, we don't complete it because it's not, it'll form a cycle. So here we go, primz and kurskal's algorithm. Okay.